Hello everyone, I'm Paul and today we're solving problem 3459, length of longest V-shaped diagonal segment. This is a reasonably hard problem, and next I will show you my intuition, approach and efficient solution. We are given a grid where each element is either 0, 1 or 2, and we need to return the length of the longest V-shaped diagonal segment according to these rules. The segment has to start with a 1, and the next element has to be a 2, then 0, then 2, then 0, and so on. And here it says that we can move in these 4 directions: top left, top right, bottom left, bottom right, and we can make at most one clockwise 90-degree turn to another diagonal. That's how we get the V-shaped diagonal. And remember, we need to return the length of the longest V-shaped diagonal segment. So let's say we have this input. Here the result is the length for this path, which is 5, so we return 5. And you can see how we are meeting every requirement. We start from number 1, so this is okay. Then after 1, we are following this sequence, 2, 0, 2, 0, and so on. We have 2, 0, 2, and 0. And we are making at most one clockwise 90-degree turn. We are changing direction right here. So it looks to me that we are taking every one in this grid as a different route, and we are trying every possible path according to these conditions to get the length of the longest V-shaped diagonal segment. And this looks a lot like a DFS problem. So let's say we're here. Initially we have 4 choices. We can move here to the top left cell, we can move top right, or bottom left. Now here we already find a base case, and it's that we are out of bounds. So in this case we just return 0. In this direction we are also out of bounds. Now let's say we go here. We start from 1 and then we need to follow this sequence. We need a 2 next, and here we have a 0, so we found another base case. If the number breaks the sequence, we also return 0. So we can also forget about this path. So finally we move here, this is a 2, and this is okay because we are looking for 2. So we already know that there are a few things we need to remember here. We need to remember I and J pointers, meaning the current position. We also need to remember the current target. For example, when we start, the target is 2, the first value in the sequence. Now when we are here, the next target is 0. So we need to remember this target. So this will be part of the state also. We also need to know what is the current direction. Remember, right now we are moving to the bottom right cell. So this will also be part of the state. Now we are here and we know that the current direction is bottom right. So the natural path is to follow the current direction and try to move here. But we have one clockwise 90-degree turn available. This means we have the possibility to change direction and move here. So we need to explore these 2 paths. So we need to add something to the state. We'll have a boolean which we'll call turn. And this is initially false and will tell us if we have already used our clockwise 90-degree turn or not. So at this point, this boolean is false, meaning we can move here or we can continue with the same direction. Now from here, the target is 0. And if we use our turn and we move here, this is 1, which is different from 0. So this path will return 0. So now we move here, we have a 0. We have not used our turn yet. We are following the same direction, and 0 is equal to our target, so we are good to go here. Now we are standing here, and if we follow the same direction, we are out of bounds, meaning this is our base case where we return 0. Now we have turn available, so we can use this and change direction. This is how we can move to this cell. So this is no longer available, and from 0 we are looking for number 2. Given that this is 2, we are good to go. We can go to this cell. Now we are here. Turn is not available, so the only choice here is to continue with the same direction. And from 2, we are looking for a 0. And given that this is 0, we are good to go. From here we have to continue in the same direction. We know this is out of bounds, so here we return 0, we reach our base case. And this is how we get this path, which has a length of 5. Now these are just some different scenarios if we start from this route. But we need to run a different DFS for every one in this grid. So after running every DFS, we find the length of the longest V-shaped diagonal segment and we return that number. And I think that the key here is to understand what is the requirement for our state. We need to carry with us these variables for each DFS and for each path. So with this in mind, let's go with the code and hopefully you will get the idea. First we say n is the length of grid, m is the length of grid 0, and here we'll have an array to store directions. And here is important to follow clockwise order. Why? Well, because we need to move from one direction to the next direction in clockwise order. And the first direction will be top left, which is -1, -1. Then we have top right, which is -1, 1. Next we have bottom right, which is 1, 1. And finally we have bottom left, which is 1, -1. So just to be clear, this is top left, top right, bottom left. Now we can create our DFS function, and remember we are carrying a state with us. And here we need to include I, J, target, turn, which is initially false, and the current direction. First we have our base cases, so if I is smaller than 0, or I is greater or equal to n, or j is smaller than 0, or j is greater or equal to m. So if we are out of bounds, or grid I, j is different from the current target, we just return 0. Else we can update target and continue. So target is now 0 if target was 2, else it's 2. Now the new I will be I plus directions at the current direction 0, and the new j is j plus directions at the current direction 1. Now we'll have a variable total, which is initially 0, and after all of this we want to return total. And now here in between we say if turn is true, this means our turn is no longer available. So we need to move in the same direction. And this means total in this scenario is the maximum among total and DFS with new I, new j, target, remember this is the new target, true because turn will never be available again, and the current direction plus 1, okay? Because remember we are returning 0 in our base case, so here we need to add 1 for every successful scenario. Now else, meaning if turn is false, we have two options. We can move in the same direction, or we can change direction. So if we decide to move in the same direction, this is total equals the maximum among total and DFS with new I, new shay, the new target, false, because remember we are deciding to move in the same direction, but the turn is available here, and the current direction plus 1. Now if we decide to change direction, the new direction is direction plus 1, but it might be a case that this is 3, and 3 plus 1 is 4. So if we add 1 here, we want this to be 0. So here we need to add modulo 4, okay? And in this case, new I will be I plus directions at new direction 0, and new shay is shay plus directions new direction 1. And now we can say total is the maximum among total, and DFS new I, new shay, the new target, true because now we are using our turn, and new direction plus 1. So now we have our DFS and we can get the result. This will be initially 0, and now for every cell in the grid, so for I in range n, for shay in range m, if the current cell is a 1, we have a root for a new DFS. So we can try every direction from the root. So for every direction in range 4, the result is the maximum among the result, and DFS with I plus directions at the current direction 0, shay plus directions at the current direction 1. We start from a target of 2. Remember, from 1 we are looking for a 2, and we have our turn available, so this is false, and the current direction is D, and we need to add 1 for the first element in this path. So finally, after all of this, we can just return result. So this is it for the code. Now let's submit this and see if it works. This is new D, so let's fix this and try again. And here I was missing a very important part, and it's that we need to cache every possible state, meaning we are storing the result for every combination of I, shay, target, turn, and direction, because we want to avoid repeated work here. Otherwise this will throw TLE, time limit exceeded. So now let's try again. As you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.